NASA flooded headlines with eclipse warnings, safe viewing tips, media coverage, and public alerts. But behind the spectacle, something far stranger unfolded. An interstellar object, 3I Atlas, was struck by a solar eruption and vanished behind the Sun. For 3 days, agencies went silent. No updates, no tracking, no explanation. What happened while the world watched the sky darken? And why did the real story unfold where no one was looking? On the 3rd of November 2025, NASA issued widespread alerts across official social media, press bulletins, and televised briefings. The message was simple: protect your eyes. A partial solar eclipse was expected to darken skies across the Northern Hemisphere for nearly 2 hours, from 1310 UTC to 1515 UTC, depending on location. Public safety reminders flooded online feeds, but the level of coverage stood out. NASA's Solar Dynamics Observatory and GOES-19 satellites released continuous educational posts about solar activity, coronal mass ejections, and how eclipses help calibrate solar models. For 2 consecutive days, November 2nd and 3rd, the agency pushed outreach more aggressively than usual, even hosting a live Q&A from Houston. On the surface, it looked routine, but insiders noted the timing. These updates arrived precisely when data concerning 3I Atlas, an interstellar object discovered on the 1st of July 2025, had gone dark. While the world watched the moon cross the sun, no one noticed that something far stranger was unfolding on the other side of the light. The contrast between openness and omission was striking. NASA's clarity about a predictable eclipse only deepened the mystery of its silence about a visitor from another star. One phenomenon was public, safe, expected. The other, potentially revolutionary, was locked away in encrypted data servers. When the eclipse faded and sunlight returned, something else remained hidden. For 3 days, NASA and the European Space Agency issued no updates on 3I Atlas. No spectra, no coordinates, no tracking notices. It wasn't an oversight, it was an absence. And in astronomy, silence often means something extraordinary has occurred. Between the 21st of October and the 3rd of November 2025, while the world prepared for the eclipse, 3I Atlas entered its most critical phase. The Asteroid Terrestrial Impact Last Alert System in Chile first detected this body in July 2025, confirming it followed a hyperbolic orbit not bound to our Sun. That made it only the 3rd known interstellar visitor, after Oumuamua in 2017 and 2I Borisov in 2019. What should have been a historic monitoring campaign went strangely quiet. NASA's Deep Space Network, responsible for continuous tracking, issued no telemetry updates after the 21st of October, coinciding with the object's solar conjunction when it slipped behind the Sun from Earth's view. Normally, automated logs remained public, but suddenly feeds froze. The ESA postponed its JUICE mission briefing, which had included commentary on monitoring data. Even independent sources noticed. Amateur observatories from Thailand, Spain, and Arizona reported missing data from official catalogs. Astronomers checking public repositories found that new orbital solutions had simply stopped uploading. For 72 hours, 3I Atlas might as well have vanished from the sky. Yet this wasn't due to hardware failure. All primary satellites, SOHO, Stereo A, and GOES-19, were online transmitting normal solar data. Only information related to this object disappeared. That kind of precision blackout suggested coordination, not coincidence. The silence felt deliberate. Then came the eruption on the 21st of October, just as 3I Atlas crossed behind the Sun. SOHO recorded a massive coronal mass ejection. Most CMEs fire randomly across the solar disk, but this one was different. Its plasma arc traveled almost perfectly along the object's path, as if the Sun itself had taken aim. Timing is everything. At 0437 UTC on the 21st of October 2025, the Solar and Heliospheric Observatory captured a violent CME erupting from active region 3876 near the solar equator. The outflow velocity was measured at 1/800 km/s, and its direction unusually aligned with the ecliptic plane where 3I Atlas was traveling toward perihelion. Within 3 hours, solar physicists at NASA Goddard noted that the CME's central trajectory overlapped almost perfectly with the comet's predicted corridor. Statistically, the chance of such a hit was less than 0.1%. The ejection wasn't headed toward Earth, Mercury, or Venus, only toward this fast-moving interstellar object. It looked accidental but unnervingly precise. As the plasma cloud expanded, data began to flicker. GOES-19 lost coronagraph updates for 48 hours. Stereo A telemetry froze at 0512 UTC. Even the Deep Space Network reassigned several dishes without notice. Inside NASA's Mission Operations Center, staff labeled the timing non-coincidental, though no statement reached the public. What followed was an information blackout. The CME struck the projected coordinates of 3I Atlas around the 22nd of October 2025, just as the object entered its period of optical invisibility. For 3 days, not one official dataset updated. What began as solar science started to look like containment, an intentional pause at the very moment the unexpected occurred. By the 24th of October, when signals resumed, the object's light curve had changed. Its color, its rotation, even its tail orientation no longer matched predictions. Whatever the CME had done, 3I Atlas was different now. And the silence that followed wasn't just scientific. It felt strategic. As the CME plasma front reached the path of 3I Atlas, a wave of data disruption swept across major monitoring assets. First, GOES-19 coronagraph imaging halted at 0604 UTC. Then stereo A heliospheric images stopped returning telemetry by midday. These were the exact instruments designed to monitor solar system events even during solar conjunction. Simultaneously, the Deep Space Network reassigned key dishes that had been previously locked on 3I Atlas's projected reappearance point. Facilities in Madrid, Canberra, and Goldstone quietly rotated away with no public update, no emergency status, and no scheduled switch alert. Meanwhile, the ESA postponed its planned update on the JUICE mission, which had included cross-instrumental coordination with comet tracking. That event, scheduled for the 23rd of October, was scrubbed from the ESA calendar without explanation. Even archived webcast links were pulled from their server. Most revealing of all were amateur networks. Radio astronomers and small observatories in Japan, Germany, and South Africa noted the absence of data from public solar repositories. Many had subscribed to NASA's open sky telemetry feed, expecting minor eclipse interference, not total shutdown. The timing was too precise to be dismissed as accident. As systems came back online, what they found was worse than silence. The object's appearance had changed. It wasn't just dimmed, it was reshaped, reoriented. From sunward jets to reverse tails, the signals no longer matched those of a comet. Something had happened during those 3 days, and it left a mark. By the 25th of October 2025, multiple independent observers flagged a sudden deviation in 3I Atlas's light curve. Instead of predictable dimming from solar glare, the object's brightness showed erratic modulation every 9.2 minutes. These spin phase jitters weren't natural. Objects like comets tumble, but they don't modulate reflectivity with such regular intervals. An astrophysicist named Dr. P. Gomez published a simulation in a private repository. His model, based on rotational torque and angular brightness curves, suggested that 3I Atlas might be exhibiting non-random orientation control. In simpler terms, it looked like the object was turning, pausing, then turning again, not tumbling, maneuvering. More surprises followed. A telescope in Chiang Mai, Thailand, captured an apparent tail reversal, a phenomenon known as an anti-tail, where dust or gas seems to be ejected toward the sun rather than away from it. These events are rare, requiring very specific alignment and never with this intensity. Further, polarimetric filters on the ESA's Mars-based camera array showed unusual reflective spikes from the object's surface, peaking near 470 nanometers, a wavelength commonly associated with polished metal rather than dust or ice. For 3 consecutive frames, brightness surged, plateaued, then vanished. The pattern wasn't chaotic. It was responsive. And by late October, some observers weren't asking if 3I Atlas was active. They were asking if it was aware.